Section 2.3, Applications of Equations. Our objective is to solve application problems. When you are solving these application problems, these are some steps you should think about as you're going through each one. Read and determine what is being asked for. Label unknowns with variables. Draw a picture when applicable. Translate verbal into mathematical. Consolidate information into one equation or system of equations. Find all other unknowns based on the relationship in the problem. And of course, you want to check and interpret your answers. Our first example is the average of two real numbers is 41.125 and their product is 1683. Find the two numbers. The first thing what I want to do when I'm doing these problems is I like to always define my variables. So I'm going to say let x be equal to the first number. And I'm going to say y is equal to the second number. When you're finding the average of a number, remember you're adding it together, dividing it by 2. And in this case, the average of the two numbers, we're going to have x plus y divided by 2 is equal to 41.125. For the second part, we're finding the product, which means we're multiplying, so x times y equals 1683. So notice this is a systems of equations, and we have two variables that we are solving for. So when you have two variables, usually you're going to want to do some kind of substitution, solve one of the equations for one of the variables, doesn't matter which, and then substitute it into the second equation. I'm going to go ahead and solve the first equation, in this case for y. So I have x plus y over 2 equals 41.125. Multiply both sides by 2 and you get x plus y is equal to 82.25. And then of course I said I'm solving for y. You could solve for x, it doesn't really matter. So subtract the x and you get y is equal to 82.25 minus x. Now I'm going to take this right here, and since it's y equals, I'm going to substitute it into my second equation for y. So that's the next step. Now I have x times 82.25 minus x is equal to 1683. Now there's a couple different ways you can solve this problem. Notice if I were to distribute this x here, I get 82.25 x minus x squared equals 1683. Notice we have a quadratic term, which means this is a quadratic equation. So if I solve this, I can use my calculator. I can also solve it by using the quadratic formula. So in order to do that, I'm going to go ahead and set this equal to 0, and I'm going to plug it into my calculator. In order to do that, I'm just going to do, so I have negative x squared plus 82.25 x, and I'm going to subtract the 1683 to the other side and set it equal to 0. So I could use a quadratic formula in this, but let's go ahead and use our calculator since that's just what we learned in the last section. So in my calculator, I plugged it into the y equals already, and I just left it in the factored form, but it doesn't really matter. If I hit zoom 6, and of course you should be doing on your calculator as I'm doing this so you can practice, notice nothing comes up because obviously it's not really a good window for what we are looking at. So sometimes you can hit zoom, and if you scroll down to the last one, zoom 0, you'll see that zoom 0 zoom fits, so you can hit enter on zoom 0 or you can just hit 0 on your calculator and you can start to see what the graph is going to look like. Now remember, this is a quadratic graph which has a parabola shape or a U shape, so I can't see the U shape here, so that means my window's really still not that great. So I'm going to go to my window and look at it, and I obviously want to change my x values because I don't see the right half of my parabola. So maybe let's go to 50 and see what happens. And of course, if this is not large enough, I would change my window still. So we kind of get a little better of an idea, but we're still not getting exactly what we need. So I'm going to go to my window again and maybe put in 100 for x maximum. And there's the other side of my parabola. Now, I don't need all these negative space that I have, so for my window, I'm going to do my x minimum maybe at negative 500 instead. Oops, not negative 500, sorry. My minimum, yes, we'll do it negative 500, and our maximum I'm going to do at, let's do 500 as well. And hit graph. So that kind of gives me a better look, but still, it's hard to see what's going on in right there. So what I'm going to do is just go to zoom, and I'm going to zoom in on that, in the middle of that. So I'm just going to take the cursor and go kind of in the middle and hit enter. So on your screen, you could also hit zoom out, and that will do the same thing. So now, as we learned in the last section, we are going to find the zero method. So I have a 0 right here and right here. So remember, to do that, we go to second and trace, and number 2 is our 0 function. So left bound means something to the left on my graph from that point, which would be somewhere in this area down here, enter. Right bound would be somewhere on the other side. So it doesn't have to be exactly where I put it, enter, and then enter. Notice that these two arrows right here, your point should be in between them so that your graphing calculator can calculate it. So when it says guess right here, you can just hit enter, and it will write the equation for you. So I have x equals 38.25. So that's the first one. Now I need to go ahead and do the next one. So I have to do it all over again. Second, trace. We want the 0. And we're going to do left bound, and now it's something above the x-axis. Enter. Right bound would be something below the x-axis from that point. And again, it doesn't have to be exactly where I put it, but close enough, and enter. And we get x is equal to 44. Now, I'm going to go ahead and transfer these values to my other sheet. So we got x was equal to 44, and x was equal to 38.25. Now, why did I get two solutions for x? Just because it doesn't really matter which number is x and which number is y. So I could say x is 44 and y is 38.25, or I could say x is 38.25 and y is 44. In this case, it doesn't really matter. So that means that I'm going to just write if x equals 44, then y equals 38.25, or if x is equal to 38.25, then y is equal to 44. So you can just pick one of those answers. You don't have to write them both out, but I just did that so you can see. Now, again, remember we learned in Algebra 2 that we can solve quadratic equations using the quadratic formula. So I'm just going to go ahead and show you how to do that just to refresh your memory. So remember, the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. And for this equation, your a is equal to negative 1, b is equal to 82.25, c is equal to negative 1683, and then I would plug it in and get x is equal to negative 82.25 plus or minus the square root of 82.25 squared minus 4 times negative 1 times negative 1683, and that's all underneath the square root, all over 2 times negative 1. And then, of course, I would simplify that. And when I simplify my answer using my calculator, which you could check on your own, you should get 44 and 38.25. Remember, when you're doing these problems, don't round your answer to the very end, because if you round this radical part here, your solution might be off from what we got. So that's the first problem. For the next problem, it says a rectangle is twice as wide as it is high. If it has an area of 24.5 square inches, what are its dimensions? The first thing I would like to do is draw a picture. So it's twice as wide as it is high. So let's say that h is equal to the height, and it's twice as wide as it is high. So then I'm going to say the width is equal to, so W equals width. So then the width is equal to 2 times the height. And of course you can use x and y if you prefer, so I have h and 2h. Now if the area is 24.5 square inches, so area equals the height times the width, so in this case the area is equal to 2h times h, and instead of writing a for area, we know what that's equal to, which we said was 24.5. Now all I have to do is solve this equation, so I have 24.5 equals 2h squared. Now this is a pretty simple quadratic equation, so rather than plugging in my calculator, it would be easier just to solve by dividing both sides by 2, so you get 12.25 equals h squared, and then taking the square root of both sides. Remember, when you take the square root, you have to do plus or minus your answer, so h is equal to plus or minus the square root of 12.25. So when you do that, you get h is equal to plus or minus 3.5. Now, you also have to think in this problem, we're talking about the length of and the width of a rectangle. So length and width, you're not going to have a negative length or a negative width. So we can't use the negative answer. We can only use the positive answer. So really, h is equal to positive 3.5, and we're talking about inches. And then we would have to figure out what the width is equal to. So the width is equal to 2 times 3.5. So 2 times 3.5 gives me 7 inches. So the height is 3.5 inches. Width, again, equals 7 inches. Or you could write 3.5 by 7. Now, of course, we could do this on our calculator. If I did this on my calculator, I could do the intersection method. However, I usually prefer to do the 0 method. So I would set it equal to 0 like I did here. Then you can hit, remember we changed our window, so hit zoom 6 for a nice window. Then here on my graph, I see what it looks like, which is a quadratic graph. I have 2 solutions, one here and one here. So if I did the second trace and we're trying to find the 0, so number 2, I would do the left bound and right bound, and when I do that, I notice this is going to be negative 3.5 and this one would be positive 3.5. So I'm just skipping doing that step since we already did it by hand and to save a little bit of time. So that's how you would do it on the calculator, or like I said, you could do the intersection method if you prefer. A corner lot has dimensions 25 by 40 yards. The city plans to take a strip of uniform width along the 2 sides bordering the streets in order to widen these roads. How wide should the strip be if the remainder of the lot is to have an area of 844 square yards? Now, the big square, of course, would be the corner lot that we have. And right here, these is the part that we're going to be cutting out, that uniform, the strip bordering the streets. So in this case, we want this smaller square now to have an area of 844 square yards. And for this, that means we're trying to figure out how much we should cut off to be able to do this. Now, that means that this length right here is going to be x that I'm cutting off, and the length here is also x. And how do I know they're both x? Is because we're cutting the same length off. So in this case, when we're solving this, remember that if I want to start with a bigger square, it said that it had dimensions 25 by 40. So in this case, let's say that this side right here, the big side, was 24, and this big side here, we'll say is 40, so that would be yards, of course. Now, if we're cutting off x amount from this, then we have to figure out what this new length that I have right here is going to be right in blue. So we're cutting off this x amount from here to here, so it would be 40 minus x gives us this distance. So that distance would be 40 minus x yards. And for this one over here, we're again cutting off that x distance. So from here to here, we have 24 minus x. Now the next step is, how do you find the area of something? To find the area, length times width. So now we want the area of the smaller square that we have. So in this case, we're going to have 24 minus x times 40 minus x equals 844. So again, notice this is going to give us a quadratic equation if we were to FOIL and distribute and combine like terms. So we could use a quadratic formula if we wanted to solve. We can also use our calculator by doing the intersection method. If we did the intersection method, you would put this into y1 and this into y2, or we can set it equal to 0 and do the 0 method. So either are okay to do. Let's do the intersection method since we just last did the 0 method. So the first thing you're going to do is get your calculator out and plug it into your y1 and y2. Now if you're looking at this, notice that we have y2 value of 844, which is pretty high. So if I hit zoom 6, a standard window, I'm looking at my window from values of -10 to 10 for x and -10 to 10 for y. So obviously if we have 844 for a horizontal line, that's not going to probably be a very good fit. So I'm going to head and change my x maximum just to 100. If we need to make it larger, we can. And I'm going to go to my y maximum. Since it's 844, I'm going to go to 900. And then hit graph and see what happens. So notice for this graph, my parabola is opening upwards because if I were to multiply and combine like terms on this right here, notice that we have -x and -x. That would give you a positive quadratic term, which is why the parabola is opening this way. This line right up here is the y equals 844. So now I need to find this intersection here and this intersection where my arrow is right here. And in order to do that, remember you go to second, trace, and we're going to find the intersection, which is number 5. To find the intersection, you just scroll over as close as you can to where that intersection is, and then you hit enter 1, 2, 3 times. And so my first intersection ends up being, I'm going to do 62.5. So 62.5 yards is what we were talking about. And then for the second intersection, do the same thing. Second trace, intersections number 5, except for now I have to scroll all the way over to the other side. So when I do that, I would have to, again, get as close as you can, hit enter 1, 2, 3 times, and you get x is equal to 2.5 yards, I believe we're talking about. So now if I go back here for this, when we solve this, we got again x is equal to 62.5 yards, and x was equal to 2.5 yards. Now, if we look at this, again, if you think about 62.5, well, notice that if our original corner dimensions for the lot were 25 by 40, can I take away 62.5 yards? No. So I know that this is actually not a solution. I know that x has to be really equal to 2.5 yards. So the way that we would write this is that the strip should be .5 yards wide. So that would be that length of x that we have right here going around our corner lot. And again, you can solve this by using the quadratic formula, by foiling, combining like terms, and setting it equal to 0, then using -b plus or minus the square root of b squared minus 4ac all over 2a, and then solving. Okay, so the next one's a little bit harder. For this problem, it says you have already invested $555 in a stock with an annual return of 11%. How much of an additional $1,100 should be invested at 12% and how much at 6% so that the total return on the entire 1650 is 9%? Now, of course, there are a couple different ways you can do this. The first thing you should always do is start off by what your variable is going to be. So I'm going to let x be equal to the amount of money invested at 12%. Now for this, you could have let x equal the amount invested at 6%. It doesn't really matter, just changes your answer by a little bit. But I picked 12% because that's what it said first in the problem. So if x is the amount invested at 12%, then let's think about what we're doing again. So we have already invested $550 into a stock with a return of 11%. So how much an additional $1,100 should be invested at 12% and 6%? So we're adding all of these together, and we want the total to be equal to 9% of 1650. So if I am investing, so let's all kind of think about this. So this is the amount already invested, plus we need the amount that we're going to invest at 12%, plus the amount at 6% is going to be equal to the total. So we already know the amount invested is $550 times 11% because the return's 11%. So we have to write this as a decimal, so 0.11 plus, well, remember we said that how much of an additional $1,100 should be invested at 12% and how much at 6%. So if x is the amount invested at 12%, then, well, if the total's $1,100, we want to do, so then 1,100 minus x is going to be the amount invested at 6%. And then, so the next one, so for 12%, we're using x, so we have x times 0.12 plus 1,100 minus x times 0.06, because that's the 6%, equals the total. So now how do we figure out what the total is going to be? So again, it says the total return on the entire 1650 is 9%. So that means that we're just taking that total 1650 and timesing it by 9%, so 0.09. So this right here is my equation. Notice that this is going to end up being a linear equation, so the best way to solve this is just to multiply, distribute, combine like terms. So this would give me 6050 plus 0.12x. I'm going to distribute here. So then I get plus 66 minus 0.06x equals 148.50. And then combining our like terms, so we have here and here like terms, and then of course the 60 and the 60, I'm sorry, that should have been 66 and the 6050. So when we add those together, we get 126.5 plus 0.06x equals 148.50, and then subtract the 126.5 from both sides. 0.06x is equal to 22, and then the next step, divide by both sides by 0.06, and you end up with x is equal to $366.67. So remember, x is the amount that was invested at 12%, so we're investing $366.67 invested at 12%, and then to figure out how much is invested at 6%, remember we started off with $1,100 minus X for 6%, so 1,100 minus 366.67 will give us the amount invested at 6%, which is 733.33. So that means that's $733.33 is the amount invested at 6%. So that would be our solution. Okay, let's go ahead and do one more problem. For the next problem, it says a radiator contains 10 quarts of fluid, 30%, which is antifreeze. How much fluid should be drained and replaced with pure antifreeze so that the new mixture is 40% antifreeze? So for this one, I'm going to draw a picture because it helps me to kind of think about it. So here we have, it says a container, so this is our radiator that contains 10 quarts. We can't, of course, go over 10 quarts because that's all that will fit in this radiator that we have. So because of that, we want to make a new mixture. So right now, this is 30% antifreeze. We want to make a new mixture so that our new mixture is going to be instead 40% antifreeze. So we want our 10 quarts to be 40% antifreeze instead of the 30%, which it is now. Well, because we can't just add antifreeze to this, because then it wouldn't fit in the 10 quarts that we have, we actually have to take out some amount, which I'm going to call X, and then replace that amount X with antifreeze to get the new mixture. Well, if I'm taking out that X amount, we're going to say that X stands for, so I'm going to say let X equal the amount to be drained and replaced with pure antifreeze. So if something is pure antifreeze, what kind of percentage would that be? Well, something that's pure is going to be 100%. So we're taking out that X amount and we're replacing it with 100% of pure antifreeze to get our new total. So the way that you would set this up is you have 30%, and notice that we have 10 quarts, and out of that 10 quarts, we're taking out X amount. So we have 30% times the 10 quarts minus some amount that we're taking out, plus we're going to replace it with 100% of antifreeze, which is going to be the same amount that we take out here is going to be the same amount that we're going to replace it with, so, but with 100%. 100% means that we're using just the 1 right there in front, is equal to, we want our 10 quarts then to be a new mixture of 40%. And then this is the equation that I'm solving. So again, notice that this equation we have right here is a linear equation, so we can go ahead and just solve this by hand. So we get distribute here, so 3 minus 0.3 x plus x is equal to 4, and then combine like terms, and you end up with, when you do all this, I'm going to take the 3 to the other side, so I get 0.7x is equal to, subtract the 3 from the 4, 1, so x would be equal to 1 over 0.7, which is really, we don't like decimals in our fractions, so 10 over 7 quarts. So in this case, that means that we should drain drain 10 over 7 quarts and replace it with 10 over 7 quarts of pure antifreeze. So that would be our solution. So we're taking out from our original mixture 10 over 7 quarts, and we're replacing it with 10 over 7 quarts of pure antifreeze to get this new mixture of 40%. So as I said before, a lot of these problems, it's very helpful to make sure you read the problem and look to see what it's asking for. If you can, draw a picture, because that helps me out a lot. And just make sure when you're answering your problem that you are answering what was being asked, and usually you want to answer it in sentence form if you can. So then the last problem that we have right here, we can just go ahead and do in class, or you can do it on your own. It's not that difficult of a problem. And we're going to do more application word problems together in class, so make sure you bring all this with you.